Okay, what are we doing?
Counting out 100 beans of each one.
100 beans of each kind of bean?
Yep.
What kind is that?
I don't know. Guys, what kind of beans are these?
Those are navy beans.
Navy beans.
Yes.
You're dropping your lime everywhere, man.
What about those?
Pinto.
Those are pintos?
Yeah.
With the freckles on them?
Yeah.
We are weighing our lima beans.
You are doing what to your lima beans?
We're weighing.
You're doing what to your?
Oh, we're massing.
Massing. And these are?
Those are lentils.
Lentils, very nice. Harrison, what kind of beans do you have there?
Pinto beans.
Okay, now it says to pick out anyone.
Sure there's 100?
Yes.
What about that half a bean there in the middle?
We had another half too.
Oh, good.
37.16.
What kind of beans are those?
That's a good
question. Pinto.
pinto beans for sure.
Pinto beans.
Pinto beans.
Record that in the data table. What kind of beans are these?
Lentils. How do you say it?
Lentils.
Lentils.
Yes, lentils. And you're determining their mass?
Yes.
And then you're recording their mass on your data table?
Yes, right here.
You want to bet?
So I have to ask, how are you determining the average mass of those beans?
You take the mass and divide it by how many beans you have, which is 100.
Okay, so why do you have,
I didn't do it yet.
why do we have a sig fig problem?
We're dividing by 100, and 100 only has one sig fig.
Where do you get 100 from?
How many beans you have?
You counted them?
Yes.
Counting numbers have an infinite number of significant figures. So they don't,
Doesn't matter. Get rid of it.
they don't factor in.
Okay.
So,
Cool. We're
So
on.
when
Maybe
that-
don't look at ours for a
so
good
that
example.
55.79 divided by 100 would be
0.5579.
0.5579, and that's what you'd actually record for their average mass.
All right. Thank you.
Oh, thank you.
No,
So,
you're ready.
what are you doing to determine the number of beans in relative mass?
We are reaching equilibrium by setting the balance to 20.0 grams
For lima beans,
for lima beans,
and then doing what?
we're putting as many lima beans on the scale until it reaches 0.
Okay.
Who was gonna set them off?
Okay, what are you doing here?
We're finding the number of beans and the relative mass.
How are you doing that?
We're setting this to the relative mass and then see how many beans it takes to even it out.
And what kind of beans are you working with?
We're using, at the moment, kidney beans.
Oh my gosh, it takes forever.
I know, I thought it'd be like 4. Wait, it went off.
Yeah, I saw it.
So what do you get?
1, 2, 3, 4, 5, 6,
18.
18.
18. Is that 18?
18. Well, count them again, just to make sure.
Yeah.
18?
18 is what I put down.
Well, they're all really close, though, aren't they? Is that suspicious?
No. I have a question.
Okay.
If we're trying to, I set it at 21.50,
Why?
and because we have to find the relative mass.
You have to find the number of beans in the relative mass.
Yes, exactly.
Okay.
So I put it on, 21.50,
Okay.
and this went like over. So how do I make it like even?
Take a bean off.
I know, but then it goes under.
About the same amount?
I mean, this is the closest I can get. It's a little over.
Get
Well, then
navy
I guess
beans.
we'll just have to do
Get
with that.
navy beans.
Cause watch.
Take one bean off, and it crashes down.
Yes.
If you put one bean on, okay.
I've screwed the hand.
Do the directions say until it reaches equilibrium?
Yeah, equilibrium
So,
is reached.
because this thing isn't pegged at the top, we can say that that's
It's reached.
equilibrium.
Yes.
Okay, sweet.
Exactly.
How many beans?
Oh, you gotta count how many. Just count how many.
I got
17? Where are you going to put that on the data table?
down here.
Okay, put it in there.
She's going to track. Make sure I count.
Oh, okay.